Hi guys! Salamat sa inyong patuloy na ginagawang pagsubaybay dito sa ating discussions about mechanics of deformable bodies. At ang ating magiging discussion for today is all about unsymmetrical beam at meron tayong inihanda ditong pangalawang problem about the topic. Sa sample problem na ito guys ay makikita natin yung ilang techniques on how we are going to solve the moments of inertia of the beam cross-section, lalo na kapag ang section natin ay unsymmetrical. Kaya subaybayan nyo guys itong ating discussion at sana patuloy nating i-subscribe itong channel natin para tuloy-tuloy ang ating information, ng ating updates ukol sa ating mga future uploads. So guys, ito yung ating problem. So, the inverted T-section of an 8-meter simply supported beam has the following dimension as shown in the figure. The beam carries a uniformly distributed load of an intensity W sub O over its entire length. Determine the maximum W sub O that can be carried by the beam if the allowable stress in tension is 80 megapascal and the allowable stress in compression is 140 megapascal. So guys, in our problem, we are given the cross-section of the beam, an inverted T, na kung saan yung kanyang mga dimensions ay given. Okay, this beam will support a uniformly distributed load W over the entire length. Okay, na kung saan yung kanyang span is 8 meter. And the maximum allowable stresses in tension and in compressions are given. So that the maximum allowable stress in tension is 80 megapascal, while that of the maximum allowable stress in compression is 140 megapascal. Ito guys yung sinasabi natin na kapag ang ating material ay magkaiba ng kanyang maximum capacity. Specifically, kapag ang tinutukoy natin ay kanilang strength to resist tension and compression, it is a good idea to consider designing an unsymmetrical beam. Kaya nga meron tayo ditong inverted T that will support the uniformly distributed load. Ang hinahanap natin, ano yung pinakamataas o pinakamalaking magnitude ng W sub O para hindi masira itong ating beam. It is also asked in the problem to determine how will the maximum W sub O be changed if the section is inverted to become a T-section. So, halimbawa daw na kung itong section natin ay binaligtad natin at ginawa nga nating T-section. So, itinatanong sa atin, how will the maximum W sub O be changed? Ano daw ang mangyayari doon sa kanyang maximum W sub O? Okay? So, sa makatuwid, meron tayong dalawang tanong dito. Yung isang tanong is the maximum intensity W kapag ito yung ating section. Yung pangalawang tanong, kapag binaligtad natin yung ating section at ginawang T, ano rin yung kanyang maximum intensity of W sub O. So, let's start guys with our solution by illustrating the situation. Para sa situation na ito, madali nating makuha yung kanyang maximum bending moment. So, in our problem, we are given here a simply supported beam of span 8 meters. This beam will be carrying a uniformly distributed load W, which should be expressed in kilonewton per meter. And because we have here a symmetrical loading, we can expect that the reaction at the supports are equal and they will just share the total loading so that the total intensity of the reaction at the support will be equal to W sub O times L over 2. Kaya kung ipapakita natin ito, meron tayong W sub O times L over 2 dito, ganoon din sa right support, W sub O times L over 2. Kaya kung isasubstitute natin yung ating length na 8 meters, it will just be equal to 4W. So for the meantime, ipinakita ko na munang W sub O kasi mahalaga na ma-recall natin o kaya matandaan natin ano ba yung resulting reactions kapag meron tayong uniformly distributed load, and that is equal to W sub O multiplied by L divided by 2. And from here, pwede na tayong mag-drawing ng shear diagram. Ang ating magiging shear diagram dito will be in this form. So we shall have here 0 at the beginning, at the left support we shall have W sub O times L over 2. Then at the left of the right support we shall have here the negative W L over 2. And then finally, this can be connected by straight line, then finally it will go back to 0, so that we will have here the shape of the shear diagram. And the shear diagram cross the x-axis at the center or at midspan. Ibig sabihin, dito rin mangyayari yung kanyang pinakamalaking moment. The maximum moment will occur under it. So we have to consider here drawing our moment diagram. So the moment diagram now can be drawn such that it will start at 0. It will have the maximum value at this point, and the value will be equal to because you have a uniformly distributed load, it will be equal to WL square over 8. Or kung hindi mo ma-recall yung formula ng maximum moment due to uniformly distributed load, so you can multiply, you can get this area by multiplying WL over 2 by 1/2 of the base, and so that is equal to 1/2 of L over 2 times WL over 2, and that gives us WL square over 8. At kapag isinimplify natin, sinubstitute natin yung ating length na 8 meters, so lalabas yung ating maximum bending moment will be equal to 8W. Ano ang magiging unit itong 8W nito? The unit of the maximum bending moment, if W is expressed in kilonewton per meter and the length in meter, therefore this 8W sub O will be in kilonewton meter. That will be in kilonewton meter. And the moment diagram will be concave in the downward direction because you have a load that is directed in the downward direction. Kaya yung ating moment diagram will be concave downward, and it will be positive. At dahil positive ang kanyang maximum bending moment, ang implikasyon yon ay yung ating beam will be concave in the upward direction. Yan, magiging concavity ng ating beam. Now, anong ibig sabihin kapag nag-concave yung ating beam in the upward direction? Pag-aralan natin, kung ito yung ating section, at sabihin natin yung ating neutral axis will be somewhere here, This is our neutral axis. Ang ibig sabihin nito, kung siya ay concave in the upward direction, yung upper portion of the section, which is this part, will be subjected to compression. And the lower part of the beam cross-section below the neutral axis will be subjected to tension. So makatwid, if this will be compression, therefore, the farthest distance from the neutral axis of the fiber in compression mula dito sa punto na ito, that will be equal to Y sub C. At yung farthest distance naman from the neutral axis of the fiber in tension, mula dito sa side na ito, that would be Y sub T. Ngayon, pag na-define na natin kung alin yung Y sub C at Y sub T, then we can get now the position or the value of Y sub C and Y sub T using the principle of the moments of area. So, ang gawin natin ngayon, solve natin yung position ng neutral axis. Pag sinabi natin position of the neutral axis, since neutral axis coincide with the centroid, therefore, we solve for the location of the centroid. So, the location of the centroid, pwede nating makompute siya based with referred from the bottom or using our Y sub T. Or it can be referred from top using our Y sub C. So, if we will be using this as our reference axis, itong ating bottom, so we can use the principle of moment that the moment of the total area from the reference axis or about the reference axis shall be equal to the sum of the moments of the individual area composing our section. from the same reference axis. Kaya yung ating equation or formula will be equal to A sub t multiplied by bar sub y is equal to the summation of A y, na kung saan yung ating bar sub y, since we are referring our moment from this axis sa makatwid yung ating bar sub y, will also be equal to y sub t. And because we are talking of the individual area here, ang ibig sabihin ito, it is good to consider that this area be subdivided into smaller areas so that each area, okay, would the centroid of each area can be easily identified so that its distance from the selected reference axis can also be identified. So that if we shall be subdividing this area into parts and then using our tabulated form of computation where you have here our three columns. Okay, the first is for the individual area, the magnitude of the area. The second is the location of the centroid of that area from the selected reference axis. And the third column is the product of the area and that centroid, the distance of that centroid, called AY. So that if we will be selecting this part, this area, yung lower flange, will be our first area. This area would have an area equal to 20 multiplied by 120, and you have here our area equal to 20 multiplied by 120, that is equal to 2,400. This area would have the centroid somewhere here, and the location of the centroid from the same reference axis that we have selected will be 1/2 of 20, and that is equivalent to 10. And so that you have here a value of y equal to 10. So that if this will be multiplied, you would have the product AY, and that value will be equal to 24,000. Then the second area will be the rectangular above this flange, and the total area of this rectangle will be equal to 20 multiplied by 200. So you have here the second area equal to 20 multiplied by 200, and that is equivalent to 4,000. The location of the centroid of this area will be located here, whose distance from this selected reference axis shall be the sum of 120, diba? And that is equal to 120. And so 120 dito, kapag i-multiply natin itong dalawa nito, 4,000 multiplied by 120, so you have the product AY, and that value is equal to 480,000. Diba? Now, if you are going to add the two area, we'll be getting the total area. So that adding these two area, I will have here the total area, and the area is equal to 6,400. The location of the centroid of this area will be somewhere here. Diba? Nandito. Sa makatwid, the location of that is equal to y sub t, and that is also equal to bar sub y o kaya y sub t. And if this summation, the product of AY will be added, you have the summation of AY. And if these two shall be added, you have the sum, equal to 504,000. Now, if these values will be substituted in the formula, so that for 80 you have 6,400, for bar y you have bar sub y, and the summation of AY will be equal to 504,000. So from here, you can solve for bar sub y, which is also the same as y sub t, or the location of the centroid from the selected axis. And that value will be equal to 78.75. Now, kung ang ating y sub t is 78.75, knowing from the figure that here is our y sub c, and therefore y sub c can be computed based on the sum of the total depth of the section, that is equivalent to 200 plus 20 minus this y sub t. Therefore, we can solve for y sub c, and y sub c will be equal to 141.25 millimeter. And so we expect, therefore, that the distance of the farthest fiber in compression is equal to 141.25, while the distance of the fiber, the farthest distance of the fiber in tension is equal to 78.75. Now, pagkatapos nating makuha ngayon yung location, as well as the farthest distance of the fiber from the neutral axis, ang kinakailangan naman nating makuha, masolve, ay yung mismong moments of inertia of the cross-section. And so we shall be solving for the moments of inertia of the section with respect to the neutral axis, because we shall be using that in the flexure formula. Now, how are we going to do it? At dito, ipakikita ko yung sinasabi ko yung technique, useful technique in solving fast the moment of inertia. Maaring ang nasa isipan nyo dito is to use the transfer formula, di ba? Because you have the individual area, A1 and A2, and maybe you'll be using the transfer formula that the moments of inertia of the area 1 will be transferred from this position to the neutral axis. And the area of A sub 2 will be taken from this position transferred to this axis. Yung process ay tama. Kaya lamang it will take you time. Medyo mahaba-haba yun. Pag medyo malituhin ka, magkakaproblema ka. Ang ipapakita ko dito, yung sinasabi ko na simple technique in solving for the moment of inertia. And I would like to let you recall the formula for the moments of inertia of a rectangle about the base. Isn't it that the moments of inertia of the rectangle about an axis through the base is equal to 1/3 of b times h cube, na kung saan yung b yung width ng rectangle at yung h yun yung depth ng rectangle. Sa mga katuwid, ang magiging idea natin dito para maging madali yung ating solution is to subdivide the section into rectangles also. However, we will not be using the earlier rectangles that we have used, but rather we shall be subdividing it into rectangles so that the rectangle will have their bases coinciding with the neutral axis. Ang maganda daw, yung ating area that will be used in subdividing the cross section shall be having the base coinciding the rectangle. So, anong ibig sabihin nun? So, kung ito i-divide natin, dapat ang ating unang sa subdivide, meron tayo itong rectangle. Nakita nyo yung kulay blue. Napansin ninyo na yung kulay blue ay mayroong base that coincide with the rectangle. Hindi ko kinuha yung entire green, kundi hanggang dun lamang yung aking blue. Diba? Yung second area ko will be the area that will cover the entire width, covering up to the neutral axis. Kaya lamang pag yan, sobra yan, di ba? Kasi meron tayong na-cover na hindi naman part ng ating area. Kaya ibabawas natin itong dalawang shaded rectangle na kulay pula. That all of these rectangles, kung mapapasin natin, all of them coincide with the neutral axis as their bases. So mga katuwid, if we shall be combining the moments of inertia of all those selected rectangles, then we shall be getting the moments of inertia of the section. And to do it, let us solve for the moments of inertia. Unahin natin, yung moments of inertia, balikan ko lamang itong ating area. What will be the moments of inertia of this rectangle? If this will be the base, that would be equal to 1/3 or b h cube over 3. Anong ating b? Ang ating b is 20. Ang ating height will be y sub c. And y sub c is 141.25. So you have here 20 times 141.25 cube over 3. Diba? That is for this blue one. Now second, yung ating malaking rectangle. Diba? Also the rectangle have the same base coinciding with the neutral axis, and so therefore we can also use this formula, and the formula will be equal to the base, which is equal to 120, the height, which is equal to y sub t, representing this magnitude of 78.75, divided by 3. Therefore this becomes plus 120 times 78.75 cube divided by 3. But we have to deduct the area that was added, and these are the two rectangles, di ba? Na kung saan, kung pagsasamahin natin yung rectangles, the rectangles would have a total width of 120 minus 20 and total width of 100. So if we will be subtracting the moments of inertia of that red rectangle, this will be equal to minus 100 multiplied by the height. The height of the rectangle will be equal to y sub t minus 20, and this is equal to 78.75 minus 20 gives us 58.75. So this becomes minus 100 times 58.75 cube divided by 3. Kaya kapag sinimplify natin ito, using your calculator, you shall be getting the moments of inertia of the cross-section, the inverted T, about the neutral axis equal to 3156333.3 millimeter to the fourth. Take note that the resulting unit is in millimeter to the fourth. Now, pagkatapos nating masolve na itong ating moments of inertia, nakuha na rin natin yung ating kay y sub c at y sub t, kay alam na rin natin yung ating moment which are expressed in terms of W, and we know the allowable stresses in either tension and in compression. Therefore, we can now solve for kay the maximum allowable W that can be supported. However, this maximum allowed W will be controlled by either the maximum allowable stress in tension or in compression. Kaya this will be controlled by any of the two. So unahin natin computin if this will be controlled by the maximum allowable stress in compression. Ito yung magko-control sa kanya. And the maximum the distance of this fiber will be 141.25. So if this will be substituted in the flexure formula, that our flexure formula is equal to stress equal to MYC over I, na kung saan yung ating stress sub C is the allowable of 140, yung moment is the computed moment equal to 8W sub O, Y sub C is this value which is given at 141.25, and I which is just computed to be 3156333.3 millimeter to the fourth. So if this will be substituted, you will see this equation. You will notice that since the moment is or has a unit of kilonewton meter, this must be consistent with the units of the other term in the formula, because I have here Newton per square millimeter. Therefore, I have to convert kilonewton into kilonewton meter into Newton millimeter. And so, this would have to be multiplied by 10 to the 6. Kaya pag ito yung multiply natin 10 to the 6, the unit will be changed or will be converted into Newton millimeter. And so, every unit here will cancel. Therefore, ang matitirang unit kung ano yung bit-bit o dala-dala ng ating W, which when simplified will be a value equal to 3.91 kilonewton meter. Pero hindi pa ito yung ating sagot kasi dalawa yung nagko-control dito, dalawa yung ating pagbabasihan. Una, yung maximum allowable compression here, and the second one is the maximum allowable tensile stress that will be developed here. Diba? Kaya for the second part, we have to consider solving for the allowable stress, as controlled by the allowable stress in tension, which shall be in the fiber at this farthest position. Using the same formula, that stress equals My sub T over I. Now, if you're going to substitute the allowable stress in tension of 80 megapascal, and the value of Y sub T, which is computed to be at 78.75, using the same moment and moments of inertia, we shall be able to compute the magnitude of W sub O, and this is being controlled by the allowable stress in tension. And that W sub O will be equal to 4.008 kilonewton per meter. And so with the two values that we have, we will not be giving this as the two answers, but we shall be selecting as which of them shall be the maximum. When we say maximum, it is the maximum value that will not cause any of the allowable stress to be exceeded. And in this case, the value that will be considered as the maximum shall be the one controlled by the allowable stress in compression at 3.91. Hence, we would say that the maximum uniformly distributed load that can be carried by the beam is 3.91, and this weight is controlled by the allowable stress in compression of the beam. So, ganun natin na dinidefine yung maximum permissible load when we have unsymmetrical beam. Now, balikan natin, puntahan natin yung second question. Maganda kasi yung second question. Sabi sa second question, ito yung second question. Sabi dito, how will the maximum W sub O be changed if the section is inverted to become a T section? Okay? So, baka ipagkamali natin baka isipin natin na they would have the same maximum allowable kW even if it is used as inverted T or if it is used as the real T section. So, we will be checking it. So, ano ba mangyayari? Tandaan natin, kapag nagkaroon tayo ng, binago natin yung orientation ng ating section, okay, yung kanyang property like the location of the neutral axis will not be changed. Yung kanyang moments of inertia will not be changed also. However, yung distance of the farthest fiber in tension or in compression will be changed because the moment will remain positive. The upper portion of the beam will remain subjected to compression. And because the neutral axis will be moved at a different position, hence, Y sub C and Y sub T would also be changed. At ipakita natin ang mangyayari. Actually, ganito yung mangyayari, guys. Obserbahan natin, subukan nating pihitin itong T at tingnan kung ano yung mangyayari. Let us try to imagine. Binigyan ko siya ng animation para ma-visualize niyo kung ano ba yung mangyayari. I-animate natin siya, guys. So, halimbawa yung ating ginawa. Yun, pinihitan natin. So, ano ngayon nangyayari? Nung pinipihit natin, siguro maganda balik natin, balik natin yung pangyayari. Pinihit natin, umaangat yung ating neutral axis, di ba? Yung ating section, ay umangat. At yung ating Y sub C, because the upper portion will remain to be subjected to compression, you would notice that Y sub C natin ay lumiit at yung ating Y sub T ay lumaki. As a matter of fact, nagkaroon sila ng pagpapalitan. Yung kaninang Y sub C, naging Y sub T. At yung Y sub T natin, yun ang naging Y sub C in terms of the value. But the position remains the same. So, mga katuwid, kung babalikan natin, isasubstitute natin yung formula, ano yung mababago dito? Kung ang pinag-uusapan natin ay compression na 140, ito yung ating magiging Y sub C. And this Y sub C actually is this 78.75. Samantalang doon naman sa tension, ito yung kanyang Y sub T. At yung Y sub T nito, yun naman yung 141.25. Kaya kung mababaligtad yung ating orientation ng section, ang ibig sabihin ito, yung ating Y sub C at Y sub T, magkakapalitan lamang. Ganyan lamang mangyayari, di ba? So kung magkapalitan siya, kaya mababago ngayon yung ating W sub O. Yung W sub O dito will become 7.01. Lumaki siya kung pag-uusapan ay compression kasi nga yung compression natin lumaki yung kanyang lumiit yung kanyang area, yung kanyang position. Sabihin, this will be subjected to a lesser stress and therefore it can carry larger load. However, yung capacity ng moment due to tension will be reduced by what? By a certain amount, and this becomes only 2.23 kilonewton per meter. So, mga katuwid, with these two value that we have when the section is inverted and becomes T section, the maximum permissible distributed load that can be carried will only be 2.23. And this weight will be controlled by the allowable stress in tension of the beam. You will notice that may pagkakataon na ang nagko-control yung compression at may pagkakataon naman na ang nagko-control ay tension. Yun guys ang ating solution sa ating pinakitang problem. At sana ay nagustuhan niyo yung ating presentation at sa pamamagitan ng presentation na pinakita ko, mas lalo ninyong naintindihan kung yung paggamit ng tinatawag nating unsymmetrical beam at yung mabilis na pagkuha ng ating moments of inertia kapag meron tayong unsymmetrical section. Once again, thank you very much for watching.